So on the try-me's that you just completed, yes, you did that, didn't you? You should have gotten this for an answer for your division, and P of 3 ended up being 16. So notice here, these are alike, and then you got the minus 3, and then you've got the P of 3, so C is 3 also there. So this is always going to be true, that whenever you're doing a division, the answer that you get when you divide by x minus 3 would be the same thing as if you took that 3 and plugged it in and calculated P of 3. So that's going to lead to this next. So the P of 3 is the same as the remainder. So that's going to lead to the remainder theorem on the other side, which states if a polynomial P of x is divided by x minus c, where c is a constant, then the remainder of this division will be the same as what you would get if you evaluated P of c. So let's do this example. Use the remainder theorem and synthetic division to find P of 3. So it's asking you not to plug it in, which would be kind of complicated, 3 to the 5th power, but instead to use synthetic division. So this is my C. So my 3 is going to go inside my box right there. And then I'm going to put my coefficients. Let's see, it is in descending order, but oops, it looks like we're missing right here, we're missing the x cubed term. You got x squared, x, and then we're also missing the constant term. So you've got to, even though it's at the very end, you're still going to need to include that. So I'm going to have a 2, a minus 18, then a 0 for the x cubed term, then 90, 59, and then a 0 for the constant term right there. So then I'm going to draw the line underneath it, and I'm going to do my synthetic division. So remember, I always begin by bringing down this first number. So bring down my 2, then multiply and get 6, add negative 12, multiply and get negative 36, add and get negative 36, multiply 3 times negative 36 and get a negative 108, add and get negative 18, multiply and get negative 54, add and get 6, multiply and get 18, and then finally 0 plus 18 is 18. So remember that the remainder is the very last number, and you had to make sure you got that 0 in there to get that. So the remainder is the last number, so we would say that P of 3 is equal to 18 in order to answer that question. So pause the video and try that next one and see what you get for your answer. We'll check it tomorrow. Now let's divide h of x as x to the third plus x plus 10 by x plus 2. So again, notice that we are missing this x squared term, so there's going to be a 0x squared in there. Also notice that when we do our x minus c, that it's actually going to be x minus a negative 2 to get that plus 2 right there. So my c on this problem is going to be equal to negative 2. That looks kind of weird. Negative 2 right there. So when I come over here to do my synthetic division, negative 2 goes in the box for my divisor. Then I'll have a 1. I'll have a 0 for the x squared, a 1 for the x, and then a 10. So we'll draw our line, begin by bringing down that first number 1, then multiply, that's negative 2, add negative 2, multiply and get 4, add and get 5, multiply and get negative 10, and add and get 0. So h, we can say then that h of negative 2, because that's what we're going to plug in as my c, is equal to 0. So since the remainder is 0, the remainder theorem tells us that h of negative 2 is equal to 0. This means that negative 2, okay, you have to think back to something we've done earlier, that negative 2 is a 0 or a solution of the polynomial equation x cubed plus x plus 10. So if it's a 0, it's also a solution. And then that x plus 2 is a factor. So this kind of goes back to our navigator exploration, that x plus 2 is a factor of it if negative 2 is a 0. And we could then write, well, hang on. So then we could write then that our polynomial h of x, which is equal to x cubed plus x plus 10. So we factored it. So we found a new way of factoring. It's going to factor then into x plus 2, or that's, yeah, x plus 2, which is what we divided by, and then times what we got for our answer, which was x squared minus 2x plus 5. So that's where I've rewritten this right here, right down here. All right, so we factored that. So we have a theorem that states, the factor theorem, a polynomial p of x has x minus c as a factor if and only if p of c is equal to 0, and we know that it's a 0. So hint, just remember that if f of c is 0, then x minus c is a factor of f of x. So use the remainder theorem to evaluate p of negative 2 for this. So remember, when we use the remainder theorem, then we're going to take negative 2 and we're going to divide it in, and we got a 1, a 5, a negative 4, and a negative 20. Not missing anything this time. So doing my division, that's 1, that's negative 2, 3, negative 6, negative 10, 20, and that adds to be a 0. So we have a remainder of 0. So that means that p of negative 2 is equal to 0. And if p of negative 2 is 0, then x minus a negative 2, or x plus 2, is a factor of p of x. So on this, since p of this, I'm going to put a negative 2 right here. Since p of negative 2 is equal to 0, then x plus 2 is a factor of p of x, which means it divides without a remainder. So we can then say that x cubed plus 5x squared minus 4x minus 20, so I'm really going to put this probably down here, is equal to x plus 2 and times what my answer here was when I divided by it. So I divided by x plus 2, got this for my answer. So it's going to be then that x plus 2 times what's left over, x squared plus 3x minus 10. All right, so factor out the x plus 2 and write it this way using division. Now we can look at this 3-term thing and use the AC method on it and come up with that it's x plus 2 times x, let's see, two numbers that multiply to be 10 will be 5 and 2. This is a minus, so minus 5 and x plus 2. So we can say h of x in factored form then was p of x. P of x in factored form then is this. So division to get the first factor, and then AC method to get the last two factors. All right, so I think I have a couple over here. We're going to do those in class. So you're done.